Today I will explain one of the important topic in the structure of atom, that is the quantum numbers, and this topic is very useful for both 10th and 11th class students, and you can watch complete video. First of all, what is the quantum numbers? Why we are studying about this concept? And each electron in atom divided by the set of three quantum numbers, those are n, l and ml. And here each electron in atom described by a set of three quantum numbers, those are the n, l and ml. And here n is nothing but principal quantum number, l is the angular momentum quantum number, and m is the magnetic quantum numbers. And these quantum numbers indicate the probability of finding electron in the space around the nucleus. With the help of the quantum numbers, we can identify the electron in the space around the nucleus. The quantum number describes the space around the nucleus where the electron is finding, and we are also identified with the help of the quantum numbers energies of electron and the atomic orbitals. So this concept is very important. You can watch total or the complete video. And the first quantum number is the n. N is nothing but here it is the principal quantum number. The principal quantum number was introduced by the scientist is the Bose. Okay students, the principal quantum number was introduced by the scientist is the Bose. The principal quantum number indicated by the symbol or the letter is the small n. So just here the n is having the positive integer values, nothing but 1, 2, 3, 4 and so on. And the principal quantum numbers determine the size and energy of orbital. Once again I am repeating, by the studying of the principal quantum number, we are getting the information is the size and the energy of orbital for hydrogen atom and the hydrogen like species. Why? Because here in the Bohr's atomic theory is applicable only one electron containing element, so that here by the studying of the principal quantum number, just we have determined the size and energy of orbital and the hydrogen atom or hydrogen like atoms like helium plus and lithium plus 2 and beryllium plus 3. Why? Because in the helium plus and the lithium plus 2 and beryllium plus 3 they have only one electrons, and the energy and the size of the orbital depends upon the only the n. As here as the n values increases, so n is nothing but number of shells are increases. Once you can look at, as the n values increases, the distance between the size and the outermost shell will be increases. So here the principal quantum number mainly explain about the number of shells. For example, here it is the nucleus, and here it is the k shell and m shell, n shell and n shell, or it is the n equal to 1 or n equal to 2 and n equal to 3 or n equal to 4. Now the maximum number of electrons that can be accommodated in the given shell. So any shell, the maximum number of electrons the maximum number of electrons that can be accommodated by the using the formula is the 2n square. And here n is nothing but the principal quantum number that we are indicated by the letters of the like a k, l, m, n, or otherwise n equal to 1, 2, 3 and 4. And the size of the orbital increases with the increase the principal quantum number. For example, each and n values increases, the size of the atom is increases. For example, n equal to 1 it is very close to the nucleus, and n equal to 2 is the somewhat distance to the nucleus, and n equal to 3 it is somewhat distance, and n equal to 4 it is a far distance. So here, since the energy is required in the shifting away the negatively charged electron from the positively charged nucleus, so that the energy of the orbital will be increased with the increase the n value. Okay students, this is about the principal quantum number. Once again I am repeating. The principal quantum number was introduced by the scientist is the Bose, and the principal quantum number as the n as the positive integer values, those are nothing but n equal to 1, 2, 3 and so on. The principal quantum numbers determine the size and energy of the orbital for hydrogen atoms or the hydrogen like species like a helium plus and lithium plus 2 and beryllium plus 3, and energy or the size of the orbital depending upon the number of shell. As the n values increases, the energy of orbital also increases. So here the n values increases, the radius of orbit is increases, and distance of the electron from the nucleus also increases. So once you can look at here, so as n values increases, nucleus and outermost shell will be increases, and this is about the principal quantum number. And next quantum number is angular momentum quantum number or azimuthal quantum number. And angular momentum quantum number was proposed by the scientist is the Sommerfeld, and denoted by the letter is the L. Angular momentum quantum number was introduced by the scientist is the Sommerfeld, and denoted by the letter is the small l. And angular momentum quantum number tell about the three-dimensional shape of the orbitals. Once again I am repeating, by the studying of the angular momentum quantum number, we are getting the information of shape of a orbitals. For example, just here any given value of n is nothing but the principal quantum number, and L can have some n values. N is nothing but something of the values. And for example, here the n is the possible values are nothing but n equal to 0 to n minus 1. Therefore, the given value of n, the possible values are L equal to 0 or 1 or 2 and 3 or so on, like a n minus 1. For example, n equal to 1 and the value of L is the 0, that indicate about the it is the s orbital. And n equal to 2, the possible values are L equal to 0 or the 1, so that indicate about the p orbital. And n equal to 3, the possible values are 0 or 1 and 2, and the orbital is the d orbital. And n equal to 4, and that indicate about the n equal to 3, that is the possible values are 0, 1, 2, 3, and n equal to 4, the possible values of L are the 0, 1, 2 and 3, that indicate about the f orbital. And each shell contain of the one or the more subshells. For example, the value of L and the number of subshells. So in case the value of L is equal to 0, that is the s subshell. The value of L equal to 0, it is the s subshell, and the value is L equal to 1, that indicate about the p subshell, and the value of L is equal to 2, that indicate about the d subshell, and the value of L equal to 3, that indicate the f subshell. The value of L is equal to 4, indicate about the g subshell. So once again I am repeating here, and the L value is equal to the 0. Wherever you are observing about the L value is equal to 0, the L value 0 indicate about the it is the s subshell. So once again I am repeating, L value depending upon the n value. So L value is equal to 0, it is the s subshell. L value is equal to 1, it is the p subshell. L value is equal to 2, it is the d subshell, and L value is equal to 3, it is the f subshell, and L value is equal to 4, it is the g subshell. Now here I am trying to explain one of the table. So in the table just they have the 1, 2, 3, 4, 5 columns, that is the shell, and the principal quantum number, angular momentum or azimuthal quantum number of the subshell in the state, and the notation. So here the shell is nothing but the k shell. Here it is the I am writing here k shell, and the principal quantum number value n value is equal to the 1 in the k shell. N value is equal to 1. Once you can see here in the k shell, n value is equal to 1, and the L shell n value equal to 2, and M shell n value equal to 3, and N shell n value equal to 4. Now in the k shell n value is equal to 1. So here the angular momentum quantum number or azimuthal quantum number value is the 0. That 0 indicate about it is the one of the value, that is the s. So n equal to 1, that's why the notation is it is the 1s orbital. And next shell is the L shell, and L shell is equal to and here n value is equal to 2. The azimuthal quantum number value, maybe it is the 0 or maybe it is the 1. In case if it is the 0, that is the s orbital. In case if it is the 0, it is the s orbital, that indicate about the n value is equal to 2, that's why it is the 2s orbital, that is the 2s orbital. And next one, and LOL is equal to 2, that also indicate about the azimuthal quantum number value is equal to 1. The 1 indicate about the p orbital, the n indicate about the, so it is the p orbital, so that is the 2p, that is the 2p. And next one, and m shell. So m shell n value is equal to 3. Here we are getting three values, either the 0 or the 1 and the 2. Already previous we are observing that. And n value is equal to, sorry, number of shell m is equal to m and the number of shell equal to 3. And here we are getting three values. 0 is nothing but here again s orbital, 1 is nothing but here it is the p orbital, and 2 is nothing but here it is the d orbital. So n value equal to 3, that's why here we are getting 3s orbital and 3p orbital and 3d orbital. And next one, n equal to 4, and that is equal to, here we are getting the number of azimuthal quantum number values are either the 0, 1, 2, 3 and 4. And again here we are getting the values of either the s orbital, 0 is equal to s orbital and 1 equal to p orbital, and the 2 equal to d orbital, and the 3 equal to f orbital, no need the 4. And here it is indicate about the it's a 4s orbital and the 4p orbital and the 4d orbital and the 4f orbitals. Okay students, this is about the angular momentum quantum number. Once again I am repeating, angular momentum quantum number indicated by the, proposed by the scientist is the Sommerfeld and denoted by the letter is the L. And here the angular momentum quantum number mainly give the three-dimensional shape of a orbitals. So here the angular momentum quantum number value depending upon the principal quantum number, and here n equal to 1, the possible values of L is the 0, n equal to 2, the possible values are the 0 or the 1, n equal to 3, the possible values are the 0, 1, 2, and n equal to 4, the possible values are 0, 1, 2, 3 and so on. Okay students, next one. And next quantum number is the magnetic quantum number, and the magnetic quantum number indicate the letter is the ml, and the magnetic quantum number was proposed by the scientist is the Lande. So magnetic quantum number was proposed by the scientist is the Lande. It gives the information about the special orientation of a orbital. So magnetic quantum number mainly give the information about the orientation of orbital with respect to the standard set of coordination axis. Okay, leave that. So it gives about the orientation of orbital with respect to the standard set of axis, and for any subshell, and they have the values that nothing but the 2l plus 1 values of ml are possible. These values may be having either -1 or the -l or the -l to -1 and l -2 or the 0, 1 and so on. Here we are getting some values, and the magnetic quantum number value is depending upon the angular momentum quantum number value. For example, here in the magnetic quantum number L equal to 0, L value is equal to 0, the only permitted value of ml equal to 0. So here I am applying the formula 2l plus 1 and 2 L value is equal to 0 plus 1, that is the 1, only 1 s orbital. So it is equal to the only 1 s orbital. And next one, for L equal to 1, and for L equal to 1, just here ml can be have either the -1, 0, plus 1, and 2l plus 1, that equal to 3, that is the 3p orbital. So what is here -1, 0, plus 1? That values indicate about in the p subshell they are the 3 orbitals are present. In the p subshell they are the 3 orbitals are present. Next one, for L equal to 2, ml can have -2 to plus 2 including 0. They have the 5 values. Why? Because 2 into 2 plus 1, so L value is equal to 5. That's why here they get the 5d orbitals. So 5d orbitals. So in the d subshell it mainly contain how many orbitals? We are getting 5 orbitals, 1, 2, 3, 4 and 5. Okay students, for L value is equal to 2, ml can have the minus 2 minus 1 0 plus 1 plus 2, and total we are getting 5 d orbitals. And for L equal to 3 and 2 into 3 plus 1, that equal to 7, that is the f orbitals. That meaning we are getting here 7 orbitals. Here we are getting 7 orbitals, like 1 2 3 4 5 and 6 and 7 orbitals. So the relation between the subshell and the number of orbitals here I am explaining. So once again, the relation between the subshell and the number of orbitals here I am explaining. A value of L of the subshell and the number of orbitals. And L value is equal to 0, that is the S subshell. L value is equal to 0, that is the S subshell, and number of orbitals are the only 1. And L value is equal to 1, that is the P subshell, and the number of orbitals in the P subshell are the 3. And L value is equal to 2. L value is equal to 2, that is the D subshell. Number of orbitals in the D subshell are the 5. And next one, and L value is equal to 3, and that is the F subshell, and number of orbitals in the F subshell are the 7. And L value is equal to 4, that is the G subshell. The number of orbitals in the G subshell are the 9. So once again I am repeating, the magnetic quantum number was proposed by the scientist is the Landé. Just the magnetic quantum number will give the information about the orientation of orbitals. So orientation of orbitals. Okay, and next one. Last quantum number is spin quantum number. So actually the given three quantum numbers will give the size and energy and orientation of a electron. But how the electrons are filling into the orbitals, the three quantum numbers, they are not explained. That's why they are introduced about the one more quantum number, that is the spin quantum number. So spin quantum number, we are indicate the letter is the ms, and the spin quantum number proposed by the scientists are Uhlenbeck and Gaudsmith. Once again I am repeating, the spin quantum number was proposed by the scientists are the Uhlenbeck and Gaudsmith. The spin quantum numbers denoted by the letters S or the ms, and the electrons are believed to the spin of their own axis in addition to their orbital motion. So in the spin quantum number, electron can be have only two types. One is having either the clockwise direction and other one is having the anti-clockwise direction. Or maybe in the clockwise direction of the spin we indicate like a plus of, that is the upside of arrow, and the anti-clockwise direction we indicate like a minus of a downside arrow. The spin quantum number is mainly explained about just in an orbital they have the two electrons. Out of two electrons, one of the electron is having the clockwise direction and another one is having the anti-clockwise direction. So the spin quantum number is mainly explained about the how the electrons are in the given orbital. Okay students, this is about the 4 quantum numbers. If you like my video, give me the like and don't forget to subscribe my channel. Thank you.